In this video, we're going to start a study of the set of the real numbers. I'm sure this is a set that you're very familiar with and you know lots of properties of this set, but here in this playlist we're going to try to dive a little bit deeper into the set and try to understand some of its properties a little bit better. So we're going to start first with the set of the natural numbers, that are the numbers 1, 2, 3, 4, the ones that we use for counting, right? Okay, this set has two operations. Addition, that tells me that if I take two natural numbers, then I produce a natural number, that is the sum of the two, that's m plus n. And multiplication, given two natural numbers m and n, then m times n is also a natural number. Okay, so we have these two operations. And now I want you to find a natural number x such that x plus 2 is equal to 1. And I'm sure you very quickly realize that this is absolutely impossible. So, okay, this is impossible. And in fact, if m is larger than n, we cannot find any natural number x such that x plus m is equal to n. Okay, that's a problem. How do I solve it? Well, I'm going to add 0 and I'm going to add the negative numbers, so I end up with the integers, which is the set that has all the natural numbers, 0 and the negatives. And now that we have this set, I want you to find an integer number x such that 2 times x is equal to 3. And again, you're going to tell me, hey Beatriz, this is absolutely impossible. Because you see, if m doesn't divide n, we cannot find an integer x such that m times x is equal to n. Okay, so this doesn't work. How can we solve it? I'm sure you're thinking about it. Bring the rationals. So we need to bring the set of rational numbers. And what is the set of rational numbers? Well, it's kind of the set of all the fractions, right? It's the set that has all the numbers of the form p over q, where p and q are integers, and q is not 0. Because remember, we're not allowed to divide by 0, so q cannot be 0. Okay, with this, now we are able to solve equations of the form a times x equals b. So we're able to solve any linear equation with a and b in the rational numbers. So pretty good so far, not too bad. But then, okay, I will ask you another problem. I need to find the length of the sides of a square of area 2 square centimeters. So here we have the picture of my square. So we need to solve the quadratic equation x squared equals to 2. And this doesn't have a rational solution. Like, the solution would have to go through bringing the irrational numbers because, well, we know that the solution of x squared equals 2 is square root of 2, and later we're going to show that square root of 2 is not a rational number. So, okay, we need to bring the irrationals, and then you could ask me, okay, what about the equation x squared equals negative 1? Well, that will force you to bring the complex numbers, but that's not our problem. In this course, we're going to stick just to the reals.